All right, so as you can see, we had some amazing conditions that day. I've actually never seen anything like it. From where we were on the ground looking out, you could see everything. When the airplane was up in the sun, looking back, the sun on the haze made it look like you were flying over fog. It was a bit like a one-way mirror, and as you can see, it looked really amazing, so I hope you enjoyed it. I'd like to share some updates on production for the Flickwing and also my general setup. Before I get into that, I want to talk to you about Windcatcher RC. Windcatcher RC is sponsoring this video. They're supplying the carbon for the Flickwing, the production Flickwing, and also I've been sourcing my EPP sheets that I build most of my airplanes out of from Lee for 5 or 6 years now. He's been my sole supplier of foam. This is also EPP. It's that rubberized, impact-resistant foam that I love so much. Also, Lee wanted me to bring to your attention that he is now carrying 3D Print Lab filament. They make a lot of lightweight PLA, and they make it in all the colors. So if you're printing airplanes, you definitely want to use lightweight PLA. Go check out the stuff on their website. It comes in all the colors now. As you can see, this pre-production sample is black. That was a miscommunication between us and the manufacturer. These will be white. And even though the black looks amazing, the downside is that if you were to leave this sitting in the sun somewhere between flights, it could definitely heat up and deform and would never fly right after that. So even though it looks amazing, we'll definitely be going with the white, at least for now. Also, the foam came out a little bit too heavy. It's actually exactly what the manufacturer quoted us, but because we're amazing, we didn't actually put in the density they gave us into SolidWorks to see how heavy the final airframe would be, and it was too heavy for our weight goals. So I'm actually really in love with the density of this foam. If we weren't trying to hit a weight goal, I would actually keep it exactly as is. But because we're trying to hit that 250 gram limit with all the goodies like the O3, 2S, 18650 batteries and stuff, we're gonna have to make that lighter. So we want one more batch. Hopefully we'll get that one in white and in the density that we need. And as long as everything checks out on that, we'll start shipping right after that. I apologize for how long it's taken us to get you guys this update. We have gone out trying to get film for you for a very long time, and it's been one thing after another. I forgot the radio after we drove 3 hours to an awesome site. I flew into a cave about 1,000 feet above where we were standing. I went out and did a bunch of performance testing, just trying to see how long this thing would fly in various configurations. So with a 2-cell 18650 battery and the DJI O3 unit running, at max, you're gonna get about 40 minutes of flight time. By the time you hit about 40 minutes, you probably won't even be able to climb the airplane anymore. So that really is kind of the limit with that. If I were to remove this antenna, the drag from this antenna, and turn off the DJI Air unit, you're actually gonna get about 70 minutes. So it turns out that the Air unit is almost pulling as much power as the motor and all the other electronics in the plane itself when it's flying. This thing is a huge energy hog. So, but that's on a 2-cell setup. The cruising speed for this guy is about 15 meters per second, like 31-ish miles an hour. And it handles really well. A lot of people have wanted to know what the difference between this and say the Nano Goblin is, which I also designed. It's a little bit smaller, but as you can see, the plan form is different. We have a swept wing instead of a straight wing. So how does that translate to how it flies? This plane will be able to get into some tighter spaces than the Nano Goblin. The Nano Goblin really has a hard time getting the nose up and slowing down. This one you can slow down. They're both really high performance, and the way I think of this one is more of like a rally car, and the Nano Goblin is more of a F1 car. So both very high performance, but very different. Okay, so here's a full setup. The full setup that I'm running, the camera for the Air unit goes in the nose up here, and then I have the Air unit itself in the canopy, and you can see the lengths I've gone to get cooling around this thing. This thing gets hot fast, and I also have a separate plug here so that after the autopilot has booted, I have a satellite lock and everything. I can plug the Air unit in at the last second and then go. That way the Air unit is not sitting on the ground heating up and I don't lose it in flight. I'm using a MRO, a Mayan Robotics Control 0 H7. That's probably the part that most people will disagree with me on. When I was trying to run less expensive autopilots, I ended up losing a lot of equipment and having a lot of frustration and losing a lot of time. I went to the MRO Control Zero, which I've used for a long time, and pretty much all my problems went away. Using an MRO GPS, this is a lightened DragonLink receiver transmitter. I'm getting telemetry from the plane out quite a ways, full telemetry. And then we have our Emax flight electronics, so Emax motor. That's this is an 1106. We may be a little underpowered. We're still kind of deciding whether we want to upgrade that to like an 1108 or something. And then we have a little 20 amp ESC and then Emax digital servos. And then I have my little Castle Creations BEC, which I've lightened up to power everything except for the telemetry transmitter, which powers directly off the 2-cell battery here. This is a Molicel M35A, I believe. So this one can put out about 10 amps max continuous, but it gives me a lot more flight time than say like a P26A Molicel. The compromise is that it just can't put out as many amps as fast. On a small plane like this, probably not necessary, but the point is you have a million ways to set this up. This is what's working for me. It's working fantastic, I love it, but the sky's the limit. Anything that you can get that will fit and work together, go for it. An interesting addendum to all this was talking to Wouter from AirShaper, who runs an online CFD service. Now, being a commercial product that was already finalized in molds, it didn't make the most sense other than I was just so curious to see what could be gleaned from higher order analysis. I pulled the trigger and ordered some server time, and included the parts of the overview that make me look like I sorta know what I'm doing.
Also, it might also be that this is not as problematic as it looks. We have an arbitrary value of 0 for the total pressure to indicate whether you have energy loss or not. If I change this value just slightly, it might be that this disappears while other areas are still visible. So what you can also do is just, first of all, look at the streamlines to see if there's any swirls locally, but I think it's fairly attached flow. I don't see any separation there. This is all nice. So if I look at this one, I don't see any flow separation yet, and also not on the surface. So it might be that it is just actually okay, and you don't need to do anything. Then the other question is, if you look at the lift over drag ratio, which is a good indication of efficiency. So this one is going flat. So let's take the one at 4.75 degrees. It's tricky to judge the lift over drag ratio because we have the prop in the model, right? So we have an almost negative drag, so you'll have a huge lift over drag ratio, which is not fair. It's 4 divided by 0.2, that's 20, which is not the case. What you could do as an indication, it's not entirely correct, but if you click on the body surface, you get 4.08 newtons of lift divided by this one, which is 0.427, which would be a lift over drag ratio of 9.6, which is actually quite okay for your design.
But with the vortex, that interior vortex coming off the wingtips, my thought was the solution that I'd come up with in my mind for now, other than like molded ones, which I feel like would do a lot better keeping the vortex from even separating in the first place. Would just be to do like half of the winglet on top of the wing and half the winglet on bottom, or like 2/3 on top, third on bottom. I do want to do like the flat plate CNC thing. I think it's a lot easier. It's a lot more durable. I think it's more user friendly, but I do want to reduce that vortex if at all possible.
So if there's already stuff you can deduct from the simulation here, so you can start to see what's happening. So there's a big swirl around the top of the wing here, and then there's more going on the sides. So here you can see the air diving underneath. So if you would extend your wingtip to the bottom, I think that would definitely make sense, because you would block this flow going underneath the wing. So that would be a good one. This low pressure area is really very active in this area. So maybe you can make your winglet a bit like this. That's actually, there's a bit more volume here, and then maybe horizontal, and then mirror it down towards the bottom side.
I ended up making winglets that were my interpretation of where the conversation had gone, and they turned out to be essentially identical in efficiency to the existing design, but handling was really squirrely on such a small model, as the effective dihedral of the wing was reduced. On a bigger plane I would love the neutral stability, but on this one it was a little aggressive, even for me. We'll probably stick with the current winglet design, but with Wouter walking me through the process and seeing potential problem areas that could be addressed beforehand on future products, I realized I'll be using his services a lot more. A second addendum is that the second batch of samples is in transit for evaluation. If that goes smoothly, then it is time for a production run and Flix will start shipping as soon as we get them stateside.